I think it'll just be a continuing war that we will neither win nor lose. I think the image of eliminating infectious diseases is a very, very long way away. There are so many potential invaders out there to use humans as their territory to expand in.
Susan Fischer Hoch is one of the world's leading virologists and epidemiologists. For many years, she's been investigating deadly viruses all over the world.
It's like the whole of medicine is better than reading a novel if you're looking for sheer human entertainment. You find there are more detective stories, more dramas, more life, more humanity than you can ever get out of a novel or a book. So if you like a varied life, you certainly get it. And viruses are intellectually very, very interesting and intriguing because they're so complex. Each one is so very finely tailored to the host that it works in, and it's kind of Machiavellian strategy that viruses use.
Some types of viruses are so dangerous that they can only be examined under extreme security conditions known as level 4.
The difference between viruses and other forms of life is that viruses absolutely have to live inside a cell. So they're it's a little bit like a bank robbery. The virus goes to a cell and says, okay, you're my home now, I'm taking you over, and you've got to do exactly what I want and hand over everything to me. And that cell then makes more virus, finally explodes, release the viruses, the little new viruses, and the new viruses go and find new cells, and it happens again. So viruses cannot live by themselves like bacteria can, like animals can, like plants can, like we can.
One of the first scientists to understand that diseases are often caused by small forms of life like bacteria was Louis Pasteur. In the second half of the last century, his pioneering work led to the discovery of vaccines. In his Paris laboratory, now a museum, Pasteur developed a vaccine against rabies. But he had, by accident, found the very first vaccine to combat a viral infection, without being aware of the importance of this discovery for future generations.
We have ways of visualizing viruses. They're very, very small. Smallest viruses are about 20 to 22 nanometers. That is so small you don't even want to know how small that is. But you cannot see it with the naked eye. You cannot see it with a microscope. There's no microscope that can see it except an electron microscope. But in order to do that, we have to have a high concentration of viruses because it's like looking for a needle in a haystack. Because once you have that amount of magnification, the chances of missing, if you've only got a few viruses, of missing the bit they're in is very, very high. I think there is an enormous amount that we don't know. I think it's less at the level of actually what is in the virus, what its structure is and what it contains. We can usually describe a virus down to the last molecule that's in it. But what we know less about is the way it interacts with the host cell, what it does inside the cell, and how it subverts the mechanisms of the cell for its own purposes. That I think we've got a lot to learn about, and at that point we know, I think, probably just a tiny amount of what it really does.
Perhaps that makes a virologist, someone like Pasteur, a pioneer in an uncharted territory. That certainly applies to Susan Fischer Hoch and her husband and colleague, Joe McCormick. They are both fascinated by viruses, and, like Pasteur, this fascination is further motivated by their compassion for the victims of a disease, who are desperately seeking relief. fighting viruses, understanding their complexity, and also understanding human behavior in relation to the spread of viral disease are all very, very exciting.
There's a bunch of really nice
An enormously curious man, obviously saw all sorts of things and wondered why they happened. And what was the explanation?
Did what the only thing he could do in those days, which is describe them.
And then make models of crystals to try to understand what they...
After working for many years on location in Africa and Pakistan, Joe and Susan are now working in France. Joe in Paris and Susan in Lyon. They spend their weekends together.
Adventure, curiosity, and a great deep sense of humanitarianness. She's a very humane person. She wants to, I think she wants to leave the world a little better than she found it, like a lot of people would. When you can mix that desire with one of a certain amount of adventure and desire for achievement, those are good mixes.
If you have a 22-year-old son who gets a fever and dies, and you're living in Holland, you expect somebody to explain to you why this has happened and why somebody hasn't done about it. If you are an African living in a remote village, it's just a personal tragedy, and it's one of those things. And you don't seek explanations very much further than maybe the witch doctor, or maybe the local missionary church or something else that allows you to adjust to your tragedy.
We have made a vaccine and we are able to test it in animals in the laboratory in America, and it seems to work very well.
In some parts of Africa, Lassa fever is still a deadly disease.
But the problem now is that we have to get this medicine and this vaccine and make sure that it is safe to use in people, not just animals, but in people.
For a long time, it was regarded as another fact of life in a country with poor health conditions like Sierra Leone.
You get a headache, severe headache, muscle aches and pains, and fever, and general weakness. The patient may deteriorate with nausea, vomiting, diarrhea, and may then get worse with bleeding, oozing from the gums, and sometimes bleeding from other sites, not large amounts of bleeding. What actually kills the patient and what they die of is shock.
Fighting the virus was one thing. Preventing people from getting infected in the first place was another.
Now, this is a virus which is a natural parasite, if you will, or an infection of small rodents. And it's infected at a very early age as a neonate, little baby. By the virus sets up its little factories inside the mouse and goes on for the rest of the mouse's life. And the mouse pees out virus the whole of its life in its urine and never has a day's illness as a result. So this is an equilibrium that allows the virus and the mouse to go on replicating, reproducing, whatever. Now, it just so happens that when this virus gets into man, that it causes a devastating disease.
Training local nurses and doctors was the first priority. Isolating the virus and studying its deadly mechanisms was another. All that in a country with hardly any medical facilities, let alone laboratories.
With these viruses, we're dealing with dangerous viruses, or at least viruses that are going to strike a lot of fear into a lot of people. But there you are, you're sitting out there in a town, quite a large town, which has no electricity and no telephone. And you're talking about high security labs with triple backup generators and goodness knows what else. So that's not realistic. You've got to do something that you can do out there, and you've got to do it safely. That's where experience comes in, and just a little bit of patience. So you can do it with very simple materials, and you can work out there. So what we did was diagnosis. We did not do viral culture, however. And the reason we didn't do the viral culture was because once you start growing up virus, you are making a lot of virus, and it starts to get much more dangerous. And at that point, we decided we had to stop. And so we sent those specimens to CDC Atlanta and grew the virus up there inside the level 4 laboratory there.
At the US Centers for Disease Control in Atlanta, the virus was meticulously studied, while in Sierra Leone the illness itself was investigated. This combined effort finally led to a cure. But better than a cure is the prevention of people getting infected in the first place.
Lassa Fever no go do. If you shoot the hat, if you eye the red, you pack the hat, anybody they want. No for say na Lassa, you don't get so. Lassa Fever no go do.
Teaching them about keeping rats out of their houses really worked, because in Chiguema, where we were studying Lassa Fever over many, many years, we started to run out of cases. Because we'd managed to get people to keep the rodents out of their houses. But people used to come in from villages from all around. Lord knows how they got there. They'd come down on the Poda, terrible drive. And there would be 3 or 4 of them, maybe more, and they'd be wearing all their best clothes. They'd all sit around. They say, please come to our village, we've got a problem. We have people dying.
Because she cannot hear, she cannot enjoy any dance. She used to be a very good dancer.
The project was successful. Lives were saved. But in the end, this success was swept away as war broke out.
There is no way that a project like the one we had in Sierra Leone can survive a rebel invasion. I mean, neither we can't keep our staff there. None of the rebels will know what we were doing or why we were doing it, or be able to maintain it again, certainly during the acute phase. So it's just going to disappear. What else can we say? Yes, it's terrible. And another thing, you have to consider what you're doing. You've made a difference in a small area, and yet the cynical thing that we always used to say in Africa was that most hemorrhagic fever in Africa is caused by bullets, not by viruses.
In the 70s, during her studies in the UK, Susan Fischer Hoch realized how little was known about the secret life of a virus. She was immediately hooked.
I wanted to know why these viruses could cause such dramatic disease, and to do it so fast. I wanted to know what they were doing and how they were doing it inside the host. But I was also very much attracted by the fascination of finding out how the epidemics occurred and what was actually going on in the field. So my interest always ran from the field and to the patient themselves.
Vaccines are one of the key elements in the war against disease. The principle of this was first recognized by Louis Pasteur. At the time, in the late 19th century, it was a scientific milestone, and it still is now.
Well, it's quite clear looking around this museum, which is beautiful, that he was very meticulous, that he was a superb observer. And observation, very, very careful, systematic observation, was the skill that people of his era brought to science. That's how they made their conclusions. If you look at his experiments, they're very cleanly designed. He knew what he wanted to know, he knew how to do it, and he apparently did most of it himself. So it's really very impressive. I think what we're doing now is a continuation of what he was doing.
Investigating epidemics is routine detective work. In 1976, a mysterious form of pneumonia broke out in the US. What was it? What caused it? Where did it come from? A huge inquiry led to the identification of one particular bacteria as the villain. It was named Legionella, referring to the American legions meeting in Philadelphia where the disease first broke out. 2 years later, the disease broke out in the UK. Significantly, in a hospital. Although Legionella is a bacteria and not a virus, this was the chance for Susan to investigate an epidemic.
First question you always ask is, where has that patient been? And we found all of them had been within the hospital. And that was a little bit of a surprise to us. So we said, well, okay, sounds as though it may be coming from the hospital. We already knew it was a building-associated disease.
In the US, it was thought Legionella spread through the air conditioning system and so infected humans. And now it threatened public health in the UK.
So we started to look in the new building for air conditioning, and of course there we were in South London alongside the Thames. No air conditioning. We don't use it there very much.
In her search, Susan found the first clue. The hot water system seemed to be the source of infection.
We had to follow the pipes round to find out where they were going, because we were looking for stagnant areas where the Legionella might be growing. This is before we'd figured out that the water heaters were the real source. So we used to go around all the plant rooms, crawling through little holes, sort of trying to find out where we might take a water sample from to see if we could get Legionella. Then in the hospital itself, we had to go and sample the baths and the showers and things. So at that point, we discovered the organism actually grew on the plumbing materials, actually inside the faucets, inside the plumbing systems. Plumbers' paste, they have a white paste, it grows on that very well. So what we discovered was the organism actually lives in the plumbing system of the hospital. It is a detective story, absolutely, that's what it is.
At the CDC in Atlanta, Joe McCormick's attention was caught by Susan's investigation in the UK. His professional interest would have a long-lasting effect.
I invited her to come over to spend a couple of months doing a project in the laboratory at CDC on Lassa Fever, which she did the next year. That had excellent results. Oh yes, was published. We learned an awful lot, and that led to, that particular experiment, a series of experiments, led to some much broader research out in Sierra Leone, where we have much better knowledge now about what the process is of this disease. We were able to actually study that in patients with the disease. We understand it much better now than we did then.
9 years later, they got married. Recently, they wrote a book about their experiences. Some of the facts were alarming. On their book promotion tour, they severely blamed the irresponsible behavior which can frustrate a successful war against viruses.
That's without AIDS.
Without AIDS.
We have another responsibility here. We're actually fueling this to some extent. Our own economies are fueling this. We see drug companies running around in these poor areas pushing their drugs. In countries where there's no control over prescriptions, no control over the over-the-counter drugs. And, you know, big companies, they'll come in and they'll push the latest line of drugs, and the patients will take them, the patients will think, and the doctors will think, you know, this is the latest thing, this is the latest thing. And that is fueling the increased resistance that you're starting to see out there, just plain misuse.
And, you know, we've defeated smallpox, and polio is around the corner, and measles, and many other things. And so, you know, it's not really a big problem. You should be worried about other things. Suddenly, HIV comes along, and people have to step back and say, well, maybe that wasn't so.
And work with you. It's the politicians who have got good health because they will hop on an aeroplane to get whatever advanced surgery they want, and will live in circumstances which buffers them from the harsh environment that many of their people live in. To get those people to have a will to improve their own country, I think, is the big political challenge. And that is very, very tough. And because their economy is poor and they don't have much money and they're trying to make money, they reuse these needles and syringes on multiple patients. Anything up to 10 or even 12 patients may have the same needle and syringe. And so they take the virus from one patient and just pumping it round the others. And this is what is
other countries
in Europe.
Other countries, the European countries especially, need to get involved. There need to be more resources, and politicians need to pay attention to this because it has and will continue to affect the populations here in Europe.
It is not viruses that invade the lives of humans. According to Susan and Joe, it is just the other way around. For example, it is due to human behavior that the HIV virus escaped from its cocoon in Central Africa and triggered a worldwide AIDS explosion. For generations, tribal culture and social control contained this virus, which is transmitted through sexual contact, to some villages, infecting only a few inhabitants. The decline of tradition and its moral values of behavior, the rise of overpopulated towns, and rapid forms of transportation mixed with poverty set the door wide open. The virus escaped from its habitat.
Before HIV, we got into the era where we thought we had conquered infectious diseases. You know, we'd got antibiotics for bacteria, and we knew about the viruses, and we got our vaccines lined up. And along comes HIV, and it was a complete surprise, because we didn't think with all that knowledge we would have a great plague. Because HIV in the 20th century is certainly akin to the Black Death of the 14th century. It has been a plague that has swept across the world and is killing millions of people. And it's not stopping. South Asia is just about to be so hard hit by AIDS. It's only just starting. By the year 2000, India will be the country with the single largest number of people who are infected with the HIV virus. We're running way behind that virus. Any thought we may have that you can conquer AIDS by either vaccine or treatment is impossible when you look at the population of India. First of all, you know that the cost of treating an individual patient with AIDS is outside the pocket of either you or I. So it's got to be paid for by a state that has a lot of money. How you're going to do that with a population of 2 million infected people, none of whom have any money.
The AIDS explosion, out of the blue, shows how fragile mankind is. How many viruses are out there, waiting for a chance to escape? But there are more threats. Known viruses are becoming resistant to vaccines. Others rapidly transform into new forms. And any good vaccine, like the one against yellow fever, is useless if governments don't care.
And you know what happens every year in Nigeria? They have an epidemic of yellow fever. You may say, why isn't everybody vaccinated? Good question. Good question. So the political will to get the vaccines to the people who need it, and even when the finances are there, when somebody says, I'll pay for the vaccine, here's the vaccine, it's cheap. Getting it to the people who need it requires political will locally. If you have a profoundly corrupt regime, they're not going to care. So it goes on, it goes on. So we have to deal with these things at all levels. Just sitting in a laboratory and mapping out a gene is never going to solve any problems in the field unless you have a vision of how you're going to take what you're doing to the patient, to the situation, and then eventually deal with the politics and the economic implications of the remedy that you're proposing and get it in place.
The war against viruses can be neither won nor lost, but vaccines and prevention can make the difference between a disease and an epidemic. Awareness and cooperation can make the difference. But the world has become a different place since Pasteur's time, when his inventions led to euphoria and to the general belief that mankind would soon wipe out many of the known diseases.
It would be nice to have him around to get his advice about what we're doing, which way we're going. But I do have great fortune, both Joe and I and people in France have great fortune in working with Charles Mérieux, who's the son of Marcel Mérieux, who worked with Pasteur. So we've almost got a direct line to Pasteur. It feels like that.